So welcome to this latest video 162 Math, and in this video we'll be going over the GCSE Maths higher topic of quadratic sequences. Now, as well as going through some common exam style questions, I'll also go through what it is you actually need to revise, and in the description I'll include lesson links on all the aspects of quadratic sequences for you to learn if you're not sure, and I'll also include a copy of the questions that we go through for you to have an attempt at, whether it's before or during while watching this video. Now, before we get started working through some past exam questions related to quadratic sequences, let's just have a quick overview over what it is you need to revise and what you need to know when tackling these questions. So the first thing is being able to recognize and prove that a sequence is quadratic. Now, for this, what you want to try and do is show that the double difference is the same. Now, if you have absolutely no idea what I'm talking about in any of these things that I'm highlighting, then I'll include some lesson links which goes over each of these particular specifications in more detail. So again, going back to recognize or prove that a sequence is quadratic, the double difference is the same. So in other words, when you've got, let's say, 4 terms, this is going to be the first difference, and then you're working out the double difference, and it's this number here. Whether it's positive or negative, that should be the same. Then to find the terms in a quadratic, for this what you want to do is make the term equal to the nth term and solve for n. Now n must be a positive whole number in order for it to be in the sequence. Alternatively, what you could do if you're asked to find the 10th term, which it kind of leads into the next point, is for this what you need to do is just basically sub n into the nth term. Then to find the nth term, this is where you need to then work out the double difference and go through the steps. And again, I'm not going to go through in this video, but if you're not sure about how to do that, then I strongly recommend that you watch the video that covers this. And again, a copy of that, it will be a link in the description. And then the last thing is, once you've mastered the art of quadratic nth term, is then apply that to real life situations and pattern questions, which again is going to be covered in this topic test. So without further ado, let's have a go at some of these exam questions. Now, a little reminder, if you're wanting access to these questions, all you need to do is just simply click on the link in the description below. So looking at question 1, it says the first 5 terms of a quadratic sequence are 3, 6, 11, 18 and 27. The question is asking us to work out the next 2 terms of the sequence. So what I'm wanting is this one and this one. Now, for 2 marks, personally you'd get 1 mark for writing each correct term. Do you need to work out the nth term? No. Do you need, could you? Yes. But again, it's not essential for this because obviously it's very, very time consuming. So because I know it's a quadratic sequence, it basically means that the double difference is going to be the same. So what I need to do is I need to work out what that double difference is going to be. So here I can see the difference is +3, then it goes to +5, then it goes to +7, then it goes to +9. So then from this I can see that the difference is increasing by 2. So then the next difference is going to be +11, and the next difference is going to be +13. So to find the next term, if I then do 27 plus 11, which gives me 38, so that's the next term, then I take the 38 and I add 13 to that, and I get an answer of 51. So again, easily done. Moving on to question 1b, it then says for me to work out the nth term of the sequence. So then for this, what I need to do is start by writing down the original numbers in the sequence, which were 3, 6, 11 and 18. Don't need to write all of them. So that's what the sequence is. Then if I then write down n, which is 1, 2, 3, 4. Now it's also very good practice if you then write down what n squared is going to be, just as a little reminder. So 1, and we've got 4, 9 and 16. Now if we go back to part A, we can see that the double difference is 2. So that means that n squared is going to be in the formula, which is what I've written here. So then what I then need to do is to work out how do I get from n squared to the numbers in the sequence. So here I need to add 2, here I need to add 2, here I need to add 2. and here I need to add 2. So the difference is plus 2. So that means that the nth term is going to be n squared plus the difference. And I've worked out the difference is plus 2, so the nth term formula is going to be n squared plus 2. Then moving on to question 1c, it says, is 402 a sequence in a term in the sequence rather? So for this, what I need to do is make the nth term equal to 402. And then what I then want to do is then solve this. So here I've got n squared is going to equal 400. So n equals the square root of 400. And then what I'm doing for here is when I get to my n, I want to see if it's an integer. So here n equals plus or minus 20. And n can only be a positive integer. So n equals 20. So the answer then is yes. Then moving on to question 2, it says the first 4 terms of a quadratic sequence are 9, 23, 45 and 75. And for question 2a, it says work out the next 2 terms of the sequence. So again, if I work out the difference, so here I've got plus 14, then I've got plus 22, and then I've got plus 30. So then looking at what the next 2 terms are going to be, well, I can see that the difference between 14 and 22 is going to be 6 plus 2, which is 8. Then we're looking at another 8. So then the next difference is going to be plus 8, and the difference between the next difference is going to be plus 8. So this is going to be plus 38, and this is going to be plus 46. So then to work out the next 2 terms, it's going to be 75 plus 38, which is 113. And if I then do 113 plus 46, which gives me an answer of 159. So then moving on to 2b, it says work out the nth term of the sequence. So if I start by writing down the original numbers in the sequence, which were 9, 23 and 45, I'm just going to leave it as the first 3. I can then write down what n is, so that's 1, 2, 3. Now because it's a quadratic sequence, I'm also going to write n squared. Let's use a different colour for that. So n squared is going to be 1, 4 and 9. Now because the double difference was 8, that 4n squared is going to be in the formula, so I can then work out what 4n squared is. So that's going to be the orange number times 4, so that's going to be 4, 16 and 36. Now the nth term is going to be 4n squared plus the difference. And the difference is between 4n squared and the sequence. Now again, if you've got multiple numbers in your little table of you working out, make sure that you are not getting yourself confused. So if you want I don't need the n squared one now, I can just put a line through it. So looking at the difference between those two, I've got plus 5, plus 7 and plus 9. So then the difference then has got a formula of 5, 7 and 9. So I can then work out the nth term for this. So the nth term for the difference is going to be, well, the difference is 2. So I'm going to have 2n. And then what do I have to do to 2n to get, 2 to get 5? I need to add 3. So it's going to be 2n plus 3. So then using this formula of n squared plus the diff, I know that the difference is 2n plus 3. So that means that the nth term then is going to be 4n squared plus 2n plus 3. Then moving on to question 3, it says that a sequence is generated by the nth term of 2n squared minus 5n plus 1. It says determine the first 4 terms of this sequence. So for this, what I need to do is I need to substitute n equals 1, 2, 3 and 4 into this nth term. So the first term when n equals 1, well, that's going to be 2 lots of 1 squared minus 5 lots of 1 plus 1. So then if I then work that out, 1 squared is 1 times 2 is 2, take away 5 times 1, which is 5, plus 1, which gives me an answer of minus 2. Then when n equals 2, then what I end up with is 2 squared minus 5 times 2 plus 1. And again, if this was non-calculator or a calculator, I would certainly enter my information like this. And I'll show you a much easier way if this was on a calculator to get your answers. So that's going to equal 2 squared is 4 times 2 is 8, minus 5 times 2, which is 10, plus 1, and that gives me a grand total of minus 1. Then when n equals 3, I get 2 lots of 3 squared minus 5 times 3 plus 1, which gives me an answer of 3 squared is 9, times 2 is 18, 5 times 3 is 15, plus 1, which gives me an answer of 4. And then finally, when n equals 4, I get 2 times 4 squared minus 5 times 4 plus 1. And then working that all out, I get 4 squared, which is 16, times 2, which is 32. 5 times 4 is 20, plus 1. And that gives me an answer of 13. So that means that my first four terms are going to be minus 2, minus 1, 4, and 13. Now, a quick way of doing this on your calculator is using the table function. So if you load up your scientific calculator, then go to menu and you want to select table. Then under f of x, what you want to do is enter this formula, the nth term formula. So again, you might need to use your alpha key. So here you need to make sure that you're using x. So if I've got 2 shift x, oh, I don't know what's happened there, alpha x, there we go, squared minus 5 alpha x plus 1 equals, g of x, just bypass that because I only want anything one result. The starting value is 1 because I want the first term. The end term is 4 because I only want 4 numbers. If I wanted 5, I'd just enter 5. 5's default, so you can enter 4. You want to go in steps of 1 because I want to go in increments of 1. Press equals. And as you can see, in the fx column, it actually gives me all of those substitution values. So it gives me minus 2, minus 1, 4, and 13. Then to get back to the original function of your calculator, to reset it, just press the mode up again, then press comp, and it should reset your calculator back to non-table mode. But that's how you can do this question on your calculator. Then for question 4, it says determine whether the following sequence are quadratic, give a reason for your answer. So let's have a look at this one. So here we look at the difference. So here we've got plus 3, then we've got plus 3, and then we've got plus 3. So this is going to be non-quadratic, and the reason for that is because the double difference is 0, but also it's a linear sequence, not quadratic. So something along those lines, or you could quote the nth term, which is basically 3n minus 1, which isn't quadratic. So something along those lines, any of those three would be absolutely fine. Then moving on to question 4b, we need to determine this. So here, if we look at the difference, that's plus 5, plus 7, plus 9. This is looking promising. So then the double difference then is plus 2, plus 2. So this is going to be a quadratic. And again, we can say that it's got the same double difference. And something along those lines would be absolutely fine. Moving on to 4c, we get a similar question. So again, looking at the difference, we've got plus 2, plus 6, and then we've got plus 8. So then looking at the difference between the difference, we've got plus 4 and then plus 2. So this is not going to be quadratic as the double difference is different. And there we go. Then moving on to question 5, it says work out the expression for the nth term of the quadratic sequence. Give your answer in the form of an squared plus bn plus c, where a, b and c are constant. So again, this is going to be one of the harder types of quadratic sequences we can get. So again, first things first, what we need to do is work out the double difference. So here we've got plus 11, then we've got plus, and what's that going to be, 17, and then we've got plus 23. So then looking at the double difference, we've got plus 6, so that means that 3n squared is going to be in the formula. So again, starting off with n, so I've got 1, 2 and 3. I've got n squared just to help, so that's going to be 1, 4 and 9. I've then got the numbers in the sequence, which are 1, 12 and 29. And I now know that 3n squared is going to be in the formula. So 3, so all I'm doing is just multiplying that by 3. So that becomes 3, and that becomes 12, and that becomes 27. So then the nth term is going to be 3n squared plus the difference. Now the difference between this and this is going to be plus 2. This is plus 0, and this is, sorry, that should be minus 2. And this one is plus 2. So here the difference is minus 2, 0 and 2. So now that's a linear expression. So then got to work out the nth term of this. So the nth term of the difference. And I should be able to do that ahead with practice. So it's going to be 2n because the difference is going up in positive 2. And how do I get from positive 2 to minus 2? Well, I need to take away 4. So that's going to be 2n minus 4. So then I can scrub out the difference. That's going to be 2n minus 4. And that gives me my final answer of 3n squared plus 2n minus 7. Then moving on to our last question, it says cuboids are made with small cubes. Each new cuboid is 1 cube wider and 1 cube higher than the previous cuboid. The depth of each cuboid is always 2, and we've got our diagram here, and it says, can the cuboid 7 be made of 100 small cubes? And it says you must show you working out, and this is a 5-mark question. So let me just zoom out to begin with. Now in terms of working out the total cubes, so in pattern 1, the total cubes is 4. In cuboid 2, the number of cuboids is 12. Cuboid 3, we've got 24. And in cuboid 4, we've got 40. So let's have a look at working this out. So one thing we've got to do is work out the nth term. Now there's several ways in which you could work this out. So I want to work out the nth term of 4, 12, 24 and 40. Now I'll show you the more analytical way of working that out, and then I'll show you how we can quickly do this, but that method is going to be unique to this particular question. So these are numbers in our sequence. N is going to be 1, 2, 3, 4. So then to work out the the double difference, so that's going to be plus 8, plus 12, plus 16. So then the double difference is going to be plus 4. So that means that 2n squared is going to be in the formula. Now if I just make a copy of n squared, so that's going to be 1, 4 and 9. 2n squared therefore is going to be 2 times the green number, so that's going to be 2 times 1, which is 2, 2 times 4, which is 8, 2 times 9, which is 18. So then what I then need to do is look at the difference between these. So the nth term is going to be 2n squared plus the difference. Now the difference between the numbers from this one to this one is plus 2 plus 4 plus 6. So then from this I can then work out the nth term, so that's going plus 2. So then we've got 2n, and then what do I have to need to go from 2 to 2? Nothing, so then it's just going to be 2n plus 0. So the nth term is going to be 2n squared plus 2n. Now once I know that, I can then, if I just rub out some of this, so hopefully you would never have written over your question so that you can't read it. and particularly do not rub out any of your working out. So then what I then want to do is check whether a sequence can be made using 7 cubes. So again, looking at this, well, there's a couple of ways in which you can do this. You can either make the nth term equal to 100 or sub in 7. So sub n equals 7, or make the nth term equal to 100 and then solve for n. So I would say substituting n equals 7 is probably the easiest. So the 7th term, so cuboid 7 is going to equal 2 lots of 7 squared plus 2 times 7. So 2 times 7 squared is 49, times 2 is 98, and then I've got plus 14. So 98 plus 14 is going to give me 102, 112. So is it going to be made with 100? No. And you could say because cuboid 7 will have 112 cubes, not cuboids, cubes. And there we go. Now there's a lot of working out for that, but now another way of finding the nth term. Now if I look at the dimensions of each of the models, so here I've got, well, notice that the numbers of the cuboids, so I've got 1, 2, 3 and 4. Now in terms of the number of cubes is basically the length times the height times the width. Now looking at cuboid 1 and pattern 1, so the length is 1, cuboid 2's length is 2, cuboid 3's length is 3, cuboid 4 the length is 4. So the length is always going to be the same as n. Then looking at the height of the bars, so this has got a height of 2, this has got a height of 3, this has got a height of 4, and that's got a height of 5. So again, comparing that green number to the highlighted one in yellow, to get the height, well, I need to look at the pattern number, which is n, and you just need to add 1. Then the width, now with the width of each of these, as it mentions in the question, is always 2. So then that then becomes 2. So then if I multiply each of these two things here, I get 2n, n plus 1, which ultimately becomes 2n squared plus 2n, which is exactly the same as what I found when I worked out the nth term algebraically. So a couple of ways in which you could get that nth term formula for this particular question.